Hi, my name is Axel Barrios, and, and today we will be answering assignment number 7, shaft rotations, or shaft directions. Today we will be answering all of the given problems and determining what direction will be the output. Okay, so first things first, at problem number 1, let's assume that all of these circles has teeth in them. Thus, gears, as we all know and love, are circle discs, and usually they have teeth, so they can interconnect with each other when they're rotating. Thus, here at A26, we can assume that this gear has teeth, and that's how it connects with B40 or C28. With that in mind, when A26 rotates, or this gear rotates clockwise, we can assume that when it interlocks with this gear, the rotation will be the opposite, thus making this gear rotate counterclockwise. With this rotating counterclockwise, we can assume, or we can see that the rotation of this gear, this one, would rotate clockwise, like that. Because again, the gears being interlocked opposes their initial rotation. Thus, when this goes clockwise, this will go counterclockwise. And when this goes clockwise, this goes counterclockwise, continuing this, the output gear, or G48, will show that it is moving in the clockwise rotation. Thus, the output out, uh, please bear with my penmanship, I'm only using mouse, would be I will be clockwise. Okay. With that idea in mind, that will continue on during all of the problems. Thus, we can assume na when a gear turns the other way, it goes to the other way, except when it comes to belts, which is here in problem 3. But we'll tackle problem 2 muna. So problem 2, as you can see, this imbis na clockwise or counterclockwise in terms, I'm gonna share, or I'm gonna say that this gear turns towards us, or turns downwards. I'll indicate this by putting a arrow down. So this gear turns towards us, or arrow down, thus causing this gear, the larger gear, to rotate upwards or away from us. Okay? With this gear rotating away from us, it's gonna translate that to its shaft, thus causing this part, the screw part, to rotate outwards towards the right, thus causing this gear to turn counterclockwise. With this turning counterclockwise, we can assume that this gear, this connected to this larger gear, is turning away from us. Diba? Turning towards us, actually. Thus, we can assume that it's counterclockwise. So the output here is counterclockwise. Okay. Next, I'm gonna go through this quickly because medyo time limited tayo. So ayun. Let's assume this motor, as indicated by the problem, this motor turns this belt, this gear, and this contraption with a belt to go to the right. With this going to the right, it will transfer that rotation to this smaller gear to the right. We can say that that gear turns to the right. With teeth, again, with the teeth notion, um, this larger gear, this thinner, larger gear, will be going to left, thus translating it to this smaller gear. Thus, this is going to the left. Now, since they're connected with another gear, a larger gear, this gear will be turning to the right. I'll indicate it here. With this turning to the right, turning like this, the smaller gear, this one at F, is turning to the left. Turning to the left or counterclockwise. Thus, getting the main output of this whole contraption. Let's say this is a tissue paper. The tissue paper roller is rolling the tissue paper to the left or counterclockwise. So we can say that the output here is counterclockwise. Take note, when it comes to belts, belt copies the initial gear's rotational direction to its connected gear. So let's say one gear here and another gear here is connected with a belt. Sorry sa pangat kong drawing. Pero let's say this is going to the left. Thus, with a belt, it will follow that direction and follow that direction and causing the connected gear or connected contraption or connected machine part to go to the same direction, thus following the sequence. Okay. With that in mind, we have another belt problem here. Here we can see that this larger gear is going down, thus translate to the other smaller gears. So all of these are going down or going to the clockwise direction and translating it to the belt. With the belt, it translates that rotational motion. Thus, we can assume that the belt goes down as well. The similar gears goes down. There. There. Okay. With that in mind, the similar gears goes down. As we can see, may smaller gear here na nakakonect doon sa gears over here. Thus, with that in mind, again, gears have teeth, and when the gears have teeth, it opposes the initial rotation. Thus, this gear will be going upwards. Upwards. Thus, translate this to number two, which will be going upwards as well. And with this gear, thus again with the notion that gears have teeth, the gears have teeth. This will be going down. With this going down again, opposing the motion, this gear will be rotating upwards, and that will translate all the way to this connector. And when this connector rotates upwards, let's assume that these gears have teeth. It looks like this. It looks like that. Thus, the gear connected here, the gear G, will be going downwards or counterclockwise. In this term, in this example, there is a rack. So if there's a rack, the gear over here, gear G will be only showing this part. Thus, the gear will be rotating towards the left. So the output of this part, we can say that it is going counterclockwise or left. And that's it for this video. Thank you.